Okay, today is the algebra video part 2. In this video, we're going to be learning how to write variable expressions. Okay, so this is the warm-up to see how this is going to be looking like. If I walk h steps forward and k steps back, which expression represents my total steps I took? Again, we're going to use variables to use this because we don't know how much steps you took forward or back, but we know that we can represent it by using a letter. So we have a, which is absolute value of h plus k, b, which is just h minus k, c, which is just h times k, absolute value, and d, which is h star k. Which can we already eliminate? Well, we have to look at the keyword. The keyword here uses, it uses my total, meaning there's going to be a plus sign. Now, once you learn that there's keywords, like example total, here we have the word total. Once you understand that there's keywords and you understand which symbol to use, then these kind of problems become so easy. We can eliminate B because, first of all, what if you walked 3 steps back? There'd be -3, correct? And if we walk 5 steps back, 5 steps back, right? Oh my gosh, it's so early in the morning, it's 9 in the morning, so I'm gonna get a little struggle. I'm gonna probably stutter a bit. If we were to walk 3 steps back, and each step back, we would get this. Then we would get -8. Now, why is this wrong? Because we can't walk a negative distance. This is something we can't represent. This is negative. We can't walk a negative distance. So we can already eliminate. We can eliminate C and D. Why? Because first of all, total means plus. So if we're looking for total, C is already eliminated, and so was B. So the only one is looking at is A, because you cannot walk a negative distance, right? You walk five. If you walk, symbol 3 steps forward, but then you walk 12 steps back. If you were to subtract them, you were to get -9. You would get something like negative. You would get something like -9. And -9 is something that we don't want. We don't want -9 is our answer. So first of all, we have to actually do is an absolute value. I have a question. For you. Would the absolute value of h plus k equal? That's about because again, this is a mouse pad. It's so hard. To the absolute value of h minus k. Would this be true? Would the absolute value of h plus k equal to the absolute value of h minus k? You let me know. And, well, let's look at this. If h was, like, example 5, and k was -2, this would be -2. Okay? If k was 2, -2, this would just become 5 minus -2. This will both be positive, but it won't result on this yield the same answer. But it will result 3, and this one results 7, right? If you were to take the absolute values of these, right? If you took the absolute values of these, you get different answers. So we know that they're not the same. Okay, I want to look at this little chart here, which literally helps us a lot, because once you're reading these word problems and you need to write the expression, or if you're just solving equations and they give you a word problem, when you solve equations, the first thing you need to know is literally writing the expression. Now, the key words in the problem do help us a lot. So let's look at the first one here. We said the sum of 3 and a number is what? Well, we're gonna have to know something here. N plus 3 or 3 plus n. So when we're looking at a number, we don't know what number. So if you see number, right? If you're looking at word problems with algebraic expressions, and if you see number, this is a variable. Why? Because it could be any number. We don't know. So it's going to be a variable. In this case, I chose n and s, right? So the sum is addition, right? We know the sum is the answer of an addition problem. So using the knowledge, we can already write the sum of 3 plus n, or 3 plus n, or n plus 3. Okay? The sum is addition or adding. More than is also addition. Okay? 7 plus a number, 7 more than a number. This would be n plus 7 or 7 plus n. Mostly, I would prefer 7 plus n. Okay? But they're the same thing. You get the same answer without no matter the value of n. Now let's look at this one. A number plus 2. Again, plus. Simple as that. You look at this keyword plus. You know the operation. It's addition. You look at it right back and front. It's addition. So we'll be looking at n plus 2. So you look at this plus sign here. And 2 plus n. Looking at that plus sign there. Okay. How about this one? A number increased by 8. Again, increase means addition. So this would be here. Did I make them all addition? I made them all addition. Oh my gosh. Same thing with subtraction. Subtraction would be like less than or the difference of, or like, see, the keywords help us a lot. You can just easily tell an operation, right? So I'll give you some more examples later on. Like the expression, a number x is added by 4. Sometimes they'll give you the number. So a number x is added by 4. So once you use the variable x. Added by, meaning you're using plus sign. So be x here that goes before. Plus 4. X plus 4. X minus 4, not 4x, not 4 divided by x, or not x divided by 4. These are not the same thing, too. 4 divided by x is not equal to x divided by 4. This one is correct. We have B. Added is our keyword. Keywords help us write variable expressions. Alright. Like, which expression shows the following? We have this one. So first, I just like to read expressions from left to right. So I'll look at n minus 3. But none of these show n minus 3. Now, you're very tempted to pick a... Well, first of all, knowing this, what can we eliminate? We can eliminate C. Why? Because the sum is adding, which means adding. So you're adding them. Okay? So let's look at this one. A, 3 minus n. This one is not the correct one. 3 minus n. This is what it's going to show. It is not equal to n minus 3. It's not the same. Why is it not the same? It is because that n, this is different. Give any value of n. Let's say n equals 1. So if we were to plug or substitute n for here, we would get 2. And here we get negative 2. They're not the same. So you give any value of n. 3 minus n would not equal to n minus 3. Really? Yeah. Unless n is equal to 3. N is equal to 3 is the only solution. Not 4, not 5. Those are mostly equal to its inverse, right? So if you were to plug example 5 here, it would be negative 5. This one would be 2. This would be negative 2 if n was 5. Can't type in my mouse pad. Not type, but draw. B is n subtracted from 3. Same thing. N is being subtracted, not 3 is being subtracted. It's n. So if n is being subtracted, it means 3 goes first. And then it's being subtracted from n. C is the right one, right? 3 is being subtracted from n. I mean that 3 is going to be subtracted by n. So D is the correct choice, okay? So here is how people get the other ones wrong. Again, A and B are very tempting, right? C is obviously incorrect. That's just there to throw you off. Some of these quizzes will just have a very obvious wrong answer that you can just eliminate off. That's really good. It's called the process of elimination. There's some answers and questions, but you can just take off. And there's gonna be some two to three answers that are gonna be like, dang, this looks very, very close to the answer, or dang, this just looks like exactly like it, but there's going to be one answer that's correct. It can either be that, or it could be either be a different answer. Okay, powers review. They're not exponents. They're called powers. Now, people, and again, exponent is another way to say it. Exponent is a part of power, but they're called powers. Okay. So powers is the whole thing. This is power is this, the whole thing. Exponent is a little number. So when you're, again, it's fine to call it exponent. It is actually like you're multiplying exponent. If you're and then you're just adding the exponents like magic. Later on, we're gonna learn that to multiply exponents, you just add multiply powers. You add the base. If saying you're multiplying exponents, and then you're just doing this, saying you're multiplying them, you're not multiplying exponents. You're adding them. Why? You can multiply. You can say multiplying powers, but you cannot say multiplying exponents if the rule is to add them. So if you come back from a later video and you're just looking at this and you're saying, "Oh, we're multiplying exponents," no, we're multiplying powers. But I get why exponents can be one. Okay. So exponents show repeated multiplication, just as multiplication shows repeated addition. So if we look at this, we can see 4 squared as meaning 4 multiplying 2 times. 4 is being multiplied 2 times. So something in the power of 2 or 3 has weird names. It's for the power of 2 it's just squared, for power of 3 it's just cubed. Anything after that is just raised to the whatever power it is. So look at this. This is read as 4 squared, okay? Or known as for the power of 2. This means that you multiply the base 4 2 times. Okay? It becomes 4 times 4, which is 16. Now look at this one. 4 cubed. When something's raised to the power of 3, you call it cubed. Okay? So in this case, it'll be 4 cubed. Means 4 multiplies by itself 3 times. 4 times 4 times 4. Okay? This is 64. This is literally taking 4 to the power of 2 and multiplying by another 4, which is 4 to the power of 3. And I'll tell you why this whole thing makes sense later on in these videos. Alright, now let's look at this one. 4 to the n minus 1. In exponents, we're mostly going to say 4 to the n minus 1 or like something to the something minus 1 or something to the something, unless it's 2 or 3. So this one just be, the example here would be 5 to the 4 plus 1, right? Or to 5 to the 5th. Or 5 to the 5th, yeah, 5 to the 5th. That means you multiply 5 times, which in this case, you get this number 3125. 6 to the power of 20 minus 17 would be subtracting. You can subtract them because sometimes there are going to be some weird exponents like this. So you subtract them. And I'll tell you how could be represented in a different way. But in this case, we're just going to leave it like that. 20 minus 17 is 3, and 6 to the power of 3 is just multiplying 6 3 times, which is 36 times 6, which is 216. So it'll be 216. Alright, which of these, I want you to try this yourself. Which of these shows 5 raised to the 4th power? Yeah. I'll give you these a few times, probably if you need to. And I actually want you to evaluate the expression too. Evaluate. What would it be, right? Alright, so plus to the power 4. This is already the right answer. Okay. This represents 4 raised to the 5th power. This is multiplying, and this is adding. So they're not. These are all just not the right answer. You have one true right answer, which is just your guy A. Okay, so I decided to throw all at you. Okay, this one was gonna be a little before. I decided to throw everything at you here. Just using the keywords, there's multiple keywords. Okay, quantity means parentheses, right? So we're gonna have parentheses n plus 5. Okay, quotient means division. Okay, again, there's gonna be a chart you can look online to see all the keywords. I was just looking at this. I was looking for a chart online, and in this case, all the way back here, I was very lazy, so I just took this chart and I thought it would be like, all of them, but it's just all addition, right? And like that. And I just figured that out. Yeah. So, and decrease means subtraction. Keep careful because sometimes 7 can either be minus 7 or 7 in front, right? When it is decreasing. So let's see. Okay, there's 2 answers we can obviously eliminate because quotient means division, right? We can easily just remove this one and this one. What part of multiplication? It's not multiplication. That's just multiplication. That's not no division. So that's wrong. So now, here's the tricky part. It's either 7 minus or that all the minus 7. So we want to look at 7 is 7 decreased. 7 decreased. So it's obviously going to be C. Now, why? No, this is very kind of a biased question. The wording is very weird in this question. But sometimes you can just break it down and see which one's correct. A and C A looks tempting, but C is the correct one. 7 decreased by the quotient. Okay? I get what people would not like this question. I don't like it either. I just made it up. Why do I not like that? Why do I not like my own question? Like, I made this question up. Come on, I gotta be serious. But yes, C is correct. You can debate with me in the comments, but again, the C is correct. It'll always be correct. This is absurd. Okay, so after this, we have the quiz. I gave you the answer for this one, didn't I? I gave you the answer. All right, all right, all right, all right. This is gonna be instead of squared, this will be uh cubed. All right, cubed, and this one will just be my this will be add. Again, I gave actually ignore the whole thing. Ignore it. I ignore number this one because I gave the answer by accident. I didn't really double check. Sometimes I would double check, but ignore this one. Ignore this one. Don't do this one. Okay. Unless you want, I don't know. Just don't do it. You can look at these two. So yes, this one's a hard, and I'll give you a hard one because this can be written. This button here can be written multiple ways. And when I did it myself, right, I was just looking at the problem. I wrote it myself, but again, um, when I did it, I had an answer. So I don't know if it's gonna differ. It's not all going to be the same. Like, it's all going to differ, right? Okay. So this is what I got. Okay. So I got this. This can be argued multiple ways to write this expression, but this is what I got. I tried to write it in decimals. So again, because I don't have that thing, right? I really don't know why, but again, this is how it looks like. It's x squared plus y minus 1 over the quantity of y plus 7 to square root of 2xy, all raised to the power of n over 18. This is a big jump because, like, we were just looking at this, and number x is added by 4, and then by the end, we're looking at this, and that is what we call mastery. If you got this right, or if you got something similar to this, and you're an algebra student, you just want to expand it or get the same answer, you can go ahead. This is what I would get. Okay, um, if you have a different answer for this one, you just gotta let me know, right? Just let me know. I'll check it out, right? But yeah, this is very biased. Okay, there's multiple answers, but anyways, this is part 2, and see you soon.